Hello everyone and welcome back to Mossy Maths GCSE. Today we're going to be going through a lesson on direct and inverse proportion. Now this topic is mainly for the higher tier students, and we're going to look at three questions, one of which is a 4-mark exam style question taken from a specimen paper from the AQA exam board. But it also applies to Edexcel students and other exam boards for GCSE. And we're going to go through 2 key points before we go through these questions. And if we can really tackle these questions, then we should be able to get full marks in an exam. And for the sake of 4 marks, I would say really these questions should only take 1 minute. And going off the fact that we should be taking a minute per mark, we can really save some time on these types of questions. Now the key points here on the left hand side are the things that are really the building blocks for direct and inverse proportion questions. Now with regards to direct proportion, we write it in this way. X is directly proportional to Y, and this is the symbol for directly proportional which we need to learn. We can write this as an equality, like this. X equals KY. This is the same thing as X is directly proportional to Y. Now when we say something is directly proportional to something else, what we mean is it goes up by a factor that relates to the other variable. It doesn't mean they both go up by the same amount necessarily, but it means they go up by a fixed rate each time. And it can be differing amounts. For example, if we have x equals ky, k can be any integer, any whole number. It could be 2. So as x goes up by 1, y goes up by 2, x equals 2y. It could be x is 4y, for every time x goes up by 1, y goes up by 4. Or it could even be a half. For every time x goes up by 1, y goes up by only a half. Okay? So that's what we mean by directly proportional. For inverse proportion, we still use this sign for direct proportion, although we write the right hand side of the equation as 1 divided by y. So x is directly proportional to 1 over y, which is the same thing as saying x is inversely proportional to y. And with this, we can write this as an equality, but we do it slightly differently. Rather than x equals ky, x equals k divided by y. So instead of them being multiplied together, the constant is the numerator of the fraction and y is a denominator. And the k, as I say, is just a constant value, an integer. And we call it the constant of proportionality. It's what tells us how much x goes up as y goes up, or vice versa, as x goes up as y goes down. Now the first question says the value of E is directly proportional to P. When E is 20, P is 10. Find an equation relating E and P. So what we do is we first of all identify whether it's a direct or inverse proportion. And we can see it's directly proportional to P. So we're using this here. But instead of X and Y, we're using E and P. So we have E is directly proportional to P. Now, we write this as an equality. E is therefore equal to some constant K multiplied by P. Well, we're told here that when E is 20, P is 10. So we can actually find K by putting in these values. So if E is 20 and P is 10, let's put this into this equation. 20 equals K multiplied by 10. Because remember, P is 10, so 10k. And now by rearranging this equation for k, we can find the value. K is just equal to 20 divided by 10. So k is equal to 2. And we don't have to do any more but to put this into the original equation, because we're told to find an equation relating E and P. So we simply look back at the equation we formed and put in our value of k we've just worked out. Now again, this will be worth something like 3 marks, so don't forget to do this final step, because this will be worth 2 marks, but the final 3rd mark is for saying E is therefore equal to k, which we've now found is 2, times P. So E equals 2P is the new equation, and that's the final mark. The second question, if G is inversely proportional, so underline that, to W, and when G is 4, W is 9. Then form an equation relating G and W. Now, inverse proportion, we're looking at this. So we have G is inversely proportional to W. So we can say G is proportional to 1 over W. That's the same thing as G is inversely proportional to W, okay? The next step is to rewrite this as an equality. G therefore equals, and looking back to this, K divided by W. Well, let's rearrange this for K first. We could always put the values in and then rearrange, but it's up to you how you do that. In this case, I'm going to show you the other way, which is rearranging for K first. So K, making that the value we're trying to find, the subject of the equation, it's just G times W. We multiply both sides of the equation by the fraction W. Okay? And we're told that when G is 4, W is 9. So let's put these values in. K is therefore equal to 4 times 9. Now 4 times 9 is 36. So K is 36. And now we simply go back to this and put in the value of 36. So G is just equal to K, which we found to be 36, divided by W. And that's an equation relating G and W, so that will be the full 3 marks. Now the final exam question is actually worth 4 marks because it is a more challenging example. Y is directly proportional to the square root of x. And we have a table here of x and y values, and we're told to find the value of a, which is missing in the table, for 4 marks. We start by doing what we usually would. Y is directly proportional, okay, to the square root of x. So y is equal to some constant multiplied by x. Multiplied by root x in this case. Now if you want to, you can pause the video and have a go by yourselves to see if you've got the gist of direct proportion. So if y is equal to k multiplied by the square root of x, we can then rearrange this for k. K is equal to y divided by root x. Now we know from this table that when x is 36, y is 2. So we can say k equals 2 divided by the square root of x, the square root of 36, which we should know is 6. So in this case, k is equal to 2 divided by 6, which is equal to 1/3. So the value of k is 1/3. Now let's make an equation, like we have with these questions, relating y and x. Now we know the value of k. Well, if y equals k root x, then y equals 1/3 root x, which we can write as root x divided by 3. Or we could write it as 1/3 times root x, whichever way you would prefer. And now we can find a, because a is just the x value when y is 5. So we need to rearrange this for root x. Well, root x is equal to 3 multiplied by y. Just multiply both sides by 3. And we know that y is 5 when x is a. So we can say that if root x equals 3y, then root x, in this case, equals 15. Okay? Because we've just substituted 5 in as y. So x is equal to 15 squared, squaring both sides of the equation to get rid of the square root on this side. And so x is going to be, that should be 225, yes, that's 225, which equals a, because that's the value we're told to find in the question. So hopefully you followed what we did there. We did the same as what we have for the other questions. We simply created an equation that relates the two values involved, x and y in this case. Then we substituted in the values we knew to find k, and once we had k, we then could determine the value of x by substituting in k and y, rearranging the equation for the square root of x, and then for x, which in this case was 225. So thanks a lot for watching the video. If you did find it helpful, please do leave a like. If you do have any questions on direct and inverse proportion, then just leave that below in the comments section and I'll try and get back to you as quickly as I can with a response. So thanks a lot, and I'll see you in the next lesson.